Hello, 5th and 6th grade. We are in the last section of the last chapter of the book, which means we are going to finish this textbook. That's great. And so we're going to be talking about light energy. I keep saying, I'm so sorry. That's just vocal garbage. So we're going to be talking about light these next 2 days. We're going to be reviewing at the end of the week. So I am on page 239. 239. Did you learn anything about sound energy? Mechanical wave has to travel through something. Well, when we look up at the night sky, we see stars, right? So, sound cannot travel in outer space because it needs material to vibrate on. However, light can. Otherwise, when we looked into outer space, we wouldn't see stars or planets. And so, and also, we wouldn't be warm, like our planet wouldn't be warm since light from the sun travels in through heat. So light doesn't need particles to travel through. And light is all around us, from the sun, from lamps, from cell phone screens. It can travel in straight lines. It can reflect off of things, like in a lake. If I look in my reflection in a mirror, it can bend. There are several different kinds. The kind that we can see, though, is visible light. There are 3 vocabulary words based off of the different ways that light passes through materials. Now, transparent material, as I can see here in this glass bowl, lets all light pass through them. It doesn't stop any light. I can clearly see what is on the inside, like a window, transparent. Translucent materials let some light pass through, but not all. It says wax paper and lampshades are translucent. Do you have any lampshades that are translucent at your house? Yeah, and so I can see the orange inside, but it's not as clear. Opaque, that's how you say that word, opaque, is the 3rd type of material. It does not let any light pass it. Light is passed through it. It's either reflected, which means bounced back, or absorbed, which means taken in. Now, hold a page of your interactive science book up to a light. Is it translucent, transparent, or opaque? Ah! Oh, she's going to try and do it. Oh, I do not see light go through it, so I would say your science textbook is opaque. Opaque. What are glasses? Like Mrs. Bulwark wears glasses. Would they be transparent, translucent, or opaque? They are transparent. I need them to be transparent. I drive. If they were translucent and opaque, that would not be safe. Question 2 says classify. Write the name of one object you have seen or used today that is transparent, one that is translucent, one that is opaque. All right, Mrs. Bulwark is going to do this too. So I've already talked about how my glasses are transparent, and I used them. Translucent. Mrs. Bulwark's water bottle, she would say, is translucent because not all light passes through. Some is absorbed and some is reflected. And opaque, my computer, my textbook, my clothes are opaque, so does not let light pass through it. It's either hidden, it's reflecting or absorbing things. All right. Ugh, sorry. Light waves and color. So even though sound, like I said earlier, requires things to bounce off of and travels in waves, lights also travel in waves, but they don't, it's a different type of wave. If you look at the top right here of your page, page 240, you can see the type of wave that light travels through. And we still have wavelengths and amplitudes and crests and troughs. as you can see, wavelength. Now, and it goes around page 240 to page 241. You can see the visible light spectrum right here. That's the light we can see, but there's also light waves that we cannot see. So like gamma radiation is considered a light wave. X-rays are considered light waves. Ultraviolet light are considered light waves. Infrared, microwave radiation, that's light waves, and radio waves, they're all light waves. And they're all on the electromagnetic spectrum. So they can have very long or very short wavelengths. Remember, the wavelength is the distance from one to the other, the distance between two crests. And on the left side, there isn't a lot of distance. And on the right side, on page 241, there is a lot of distance. When we see an object, the object reflects waves of visible light for us. The light enters our eyes. Different wavelengths of visible light are seen as different colors. When all the colors of visible light are mixed, we see white light. If we shine white light on an object, some bounce off the object and some are absorbed. So when I see a green leaf, all of the other wavelengths are being absorbed except for green light. Green light is being reflected back, which is why I see it as green. All right, question 3 says, why do you think an ultraviolet light is called a black light? So an ultraviolet light, why is it called a black light? People use black lights in crimes if they're trying to see like if there's blood anywhere. People use them to make fun things glow, like fluorescence and neon. There's a lot of different uses. But it's called a black light because ultraviolet light is not visible to us. The wavelength is too short. So we call it black light because according to our textbook, all the colors of visible light are white light. So we cannot see it. The wavelength is too short for us to actually see. So, as you can see for some of these, light is given off and we feel heat too. So when you feel the warmth of the sun or heat of a light bulb shining a few centimeters from your hand, we're feeling electromagnetic waves. Infrared waves feel very warm. Warm objects produce more infrared rays than cold objects. And so infrared photographs can see where like just on the previous 2 pages, page 238, you can see an infrared picture showing the different temperatures of things. Compare and contrast. Name one similarity and one difference between visible light and sound. Well, light and sound are both waves, so they're both waves. However, light can travel through empty space, while sound cannot. Remember, we have light and heat from the sun, so it's able to travel, because the sun is not touching the earth, because that would be very bad. But sound cannot travel in empty space. It needs particles to vibrate through. Just like in that sleep defense game where you put up that space block. All right, tomorrow I will pick up with this light changes direction and we'll finish the section. All right, I will talk to you tomorrow. Bye.